All right, so now we should be able to be comfortable using sine, cosine, and tangent, which are useful anytime that we are looking for the side length of a right triangle. As long as they give us the length of one side of a right triangle and an angle, we can use that information, and along with either using uh, the sine function, the cosine function, or the tangent function, these three functions here, tangent, sine, and cosine, we can use those three functions plus those two pieces of information to figure out all of the other sides of the triangle. But we're not always going to want to know what a side length is. Let's say that we already know what the side lengths are for the triangle. Let's say we know that the sides are 3, 4, and 5. And this is actually just one of those special right triangles. There are a couple of different patterns that are easy to remember, but this one just sticks out to our mind, or, to my mind, because they're in sequential order. But 3, 4, 5 does create a right triangle. Let's say we wanted to know what would the angles, the two acute angles, have to be here in order for this to be a 3, 4, 5 right triangle. We already know that this is a 90-degree angle, so that's pretty easy. Just as a quick note, don't forget that there's 180 degrees between the three sides of a triangle. So if you add these three up, you have to always get 180. Since this is always going to be 90, it's a right triangle, so one of the angles has to be 90. That means that the two angles that are left have to add up to 90. So this angle and this angle, no matter what they are, they're always going to add up to 90. So really, if I can find one of them, I can find the other one pretty easily. With all other math operations that we do, multiplying, adding, there's an opposite operation, what we would call an inverse operation, something that undoes the addition or the multiplication. For addition, if we wanted to undo an addition operation, we would use subtraction. For multiplication, if we wanted to undo that, we would use division. We know that each of these represents the ratio between two sides that is specific to one angle. Unfortunately, if we want to find the angle, these three aren't going to be very helpful because we have to put an angle into one of these in order to get the ratio out. But just like for addition and multiplication, there's an inverse function. The same is true for each of our trig functions, sine, cosine, and tangent. For each of those, we're going to get an inverse trig function. So we'll have inverse sine, or inverse tangent, or what's called arctangent. Inverse sine, which is arcsine, and inverse, that's sine again, inverse cosine. Which would be arc cosine. Now we're going to be able to use these three inverse trig functions to find an angle that creates a given ratio. So if we know the ratio, that is the input for these functions, just like the angle was the input for the other ones. So let's say we wanted to find the angle that is over here. Let's say this is A. We want to find angle A. There's a couple of different ways that we can do it. As a matter of fact, there's 3 different ways we can do it. But I'm going to use this side and this side first, just to find it this way. So that's the opposite and the hypotenuse. Now each of these inverses, they still deal with the same sides as their regular functions. So tangent still deals with opposite and adjacent. Sine is still dealing with opposite and hypotenuse. And cosine still deals with adjacent and the hypotenuse. So in this case, I'm dealing with the opposite side and the hypotenuse. That means that I'm going to be dealing with arc sine or inverse sine. So the way that I can write this out is inverse sine, and what I'm going to put into the function is the ratio that I'm dealing with. In this case, 4 over 5, opposite over hypotenuse. And that is equal to the angle A. So that is equal to the measure of angle A. Normally we would put the angle measure into the sine or the cosine function and get this ratio out. But this is actually the opposite, or the inverse. So if we put inverse sine of 4 over 5, we can see what that's going to give us in our calculator. And when we put that into the calculator, we get that inverse sine of 4/5 is equal to an angle of 53.13 degrees. So angle A equals 53.13. So like I said, we could have found this using any of these three inverse trig functions. It would have just involved the ratio of different sides. If we had used inverse tangent to find it, we would have done the inverse tangent of opposite over adjacent, 4 over 3. And that would also give us 53.13 degrees. So, don't take my word for it. I want you to check these and make sure that I'm not just, making up math stories or anything. This is true. We could also use the inverse cosine. So the inverse cosine would be adjacent and hypotenuse, or 3 over 5. Inverse cosine of 3 over 5 would be equal to, yep, you guessed it, 53.13 degrees. It's the same for all of these. As long as we're talking about the same angle, we've obviously got to get the same measure no matter which of the three inverse trig functions we use. So let's think about it for a second. If I wanted to do what's called solving the right triangle, or basically find all of the angles and all of the side measures, I would only really need to find one of these two acute angles. Remember I said that these two have to add up to 90 degrees. That means that if I wanted to find the measure of angle B, I could do it a couple different ways. At this point, I could do it 4 different ways. I could either use arc tangent, arc sine, or arc cosine to find that angle, or I could just use the fact that angle B plus angle A has to equal 90 degrees. If that's true, that means that I can find angle B by simply subtracting angle A from 90 degrees. So that means that 90 minus 53.13 has to equal angle A. And if we do that, we get 36.87 degrees. So angle A, let's see, 36.87 degrees is equal to, sorry, that's angle B. All right, and this would be the same number that you would get if you put into your calculator inverse sine of, remember that whenever we change angles, we change opposite and adjacent. So this would be inverse sine of 3 over 5. And that would give us 36.87 degrees. So whether you're using the fact that they're complementary angles, or which means they add up to 90 degrees, or that you are using the inverse trig functions, you will still get the same angle. So you can do it either way. Once you have one angle, you can find the other one, your choice of ways.